Assalamu alaikum warahmatullah. My name is Enas Al-njadat. I will talking about refractive index detector. The abbreviation of this type of detector is RI or RID. First of all, the detectors in general and in chromatography especially is a device used in high performance liquid chromatography. So this means it's specific for HPLC. And this type of detector is used to detect the component in the mixture, the composition that exists in many substances that mix in each other. Then this mixture will convert the change in it into electrical signal in order to record it by data system. This is how this type of detector works. We have 6 major HPLC detectors. The refractive index detector, which I will discuss, and we have evaporating light scattering detector, VIS, absorption detector, fluorescence detector, electrochemical detector, and finally conductivity detector. My presentation will talk about refractive index detector. First, I will make a simple introduction to RI. Then I will talking about parts of RI, mechanism of action, uses, advantages, disadvantages, and some of the application of RI, or where we use RI, or why. RI has another name. It's called the differential refractive index detector. Also, we can say it is bulk probability detector. What's the meaning of bulk probability? This means its response to some physical property of total column element and not some specific property of solute. So it is totally depend on the physical property of element and not totally on the property of solute. It measures the overall ability of mobile phase and its solute to emit the light. From its name, refractive, we have a refraction. The refraction of what? Of the light. And this refractive index measures the ability of mobile phase and solute to emit this light that refracts. And also it's measure the ability to deflect the light flowing mobile phase. And we have a direct proportion between the amount of deflection and the concentration of solute. When the concentration of solutes in the mobile phase is increased, the amount of deflection will increase. So it's direct proportion. It has low sensitivity to dirt and air bubbles in the cell. So if the cell not clean totally or 100%, it will not depend on it because it's low sensitivity to dirt and air bubble. The refractive index range from 1 to 1.75 Ri with single balanced cell. And the refractive index detector considered as universal response. The parts of refractive index detector. We have cell here that composed of 2 parts, sample cell part and reference cell part. And this light, the light is the source of the beam, and here we have deflected beam that will measure in order to know the composition of the cell sample. The mechanism of action is dependent on the incidence beam. This incidence beam or light beam will pass into this cell it will pass in the sample cell and it will deflect. The sample cell composed of many components, and here we have a reference cell. We put it here in order to compare the sample cell with reference cell. The mechanism of action to over-analysis for this mechanism, we have two media, air and glass. When the light is transported from air to the glass, it will reflect, because we have an idea that when the light is transported from one media to another, it will be reflected. Here, the first angle, we have I. Also, inside the glass, we have R, angle of refraction. Okay, from I and R, we can calculate M. M is sine I over sine R, and this law known as Snell law. M is constant, indicates the refraction index for the second media. So here we have the glass, so N is the refraction index for the glass. When the glass is changed into, for example, water, the refraction index will change. So the refraction index depends on the factors that affect on refraction index is nature of media, physical condition, and third is the color and the wavelength of light that used. Example for the color, refraction index for violet light more than red light. So when we change the light, it will reflect a change on refraction index. RI use. The main use and the universal use for RI and the common use, it's detecting the substances with limited or no UV absorption. These substances have high sensitivity to UV, so we can't use UV in these substances unless we have RI. UV absorption such as alcohol, sugars, fatty acids, polymer, and carbohydrates. All of these substances we can use RI in order to detect them. Advantages for RI is low price and easy handling, good linear behavior, and universally applicable. It's low price according to another detector, and it's universal as I talked before. Disadvantages for this type of detector, it has low sensitivity due to it's very sensitive to temperature, so we must control the temperature when we use the RI. So it's thermosensitive. It's affected by the temperature. RI also sensitive to flow variation. Cell is very fragile. The cell in the equipment is very fragile, so we must be we must careful with dealing with this type of RI. And the most common cause of low sensitivity of RI is can't used in the gradient illusion, and the gradient illusion can't used with RI, and this is the universal disadvantage. Because the element composition changed during the analysis. Because of that, we can't use this type of gradient illusion. And this ability to easily remove and clean or replace the cell when filming or clogging happen. So the cell, when we have a problem in the cell, we can solve this problem because it's not easy to remove or clean this cell. Finally, the application of RI. It helped to identify and confirm the identity of sample. How? By comparing refractive index to known value. We have a reference cell and the sample cell. We compare the sample cell with the reference cell and know the identity of the sample. Also, it helps us to assess the purity of sample by compare the sample with the pure substance, the reference pure substance for this sample, and determine the concentration of solute in the solution by comparing the solution refractive index with standard curve. We have the standard curve, we know from it the concentration of solute.